Hey, welcome to a lesson on trigonometry. We're going to be learning the first trig ratio called tangent today. So before we start, we're going to look at some labeling review. So remember, we're always working with 90-degree triangles now, and this side opposite the 90-degree triangle is called the hypotenuse. And when we're working with trigonometry, we always have to choose something called the focus angle, and I'm going to label it the theta. And now that we have a focus angle, we can actually label the opposite side across from that focus angle. And we can also label something called the adjacent, which is next to the focus angle. Now, we have two building blocks before we get to the final understanding of what tangent really is. So here's building block number one, where we're connecting our intuition to the relationship between angle and ratio. So here's a question kind of relating to grade 9. It says, what's the slope of each ramp? So we have one ramp here, we have another ramp here, we have another ramp right here. And they're different colors, but they kind of look similar. Anyways, when we're talking about slope from last year, you remember the formula is always rise over run, and rise over run, and rise over run. So they're asking us the slope for each of these, but I can't find the slope if there is no number. Now in grade 10, we're not going to give you the numbers for rise and run just yet. You might actually be given the angle, okay? And so in this case, we have a 45-degree angle with another 45-degree angle, and they're all 45-degree angles. So that makes these triangles similar, right? They're all similar shape, just proportional sides. And what makes this interesting is that if you recognize that these are both 45-degree angles here, that means this is something called an isosceles triangle. All three of these are isosceles triangles. Because the angles are equal, that means their sides must also be equal. So if the sides are equal, this is going to be the same number, and this is going to be the same number. This is going to be the same number, this is going to be the same number. This is just going to be a smaller number than all these ones, but it's going to be the same small number as this one. If you divide the same two numbers, it's going to be 1. So since all 45-degree triangles are isosceles triangles, the ratio of the rise and the run is 1. Building block number 2, connecting slope and angles. So which of these two triangles has the steeper slope? And you can pretty much see just from intuition that this is going to be a higher slope. But it's worthwhile investigating some of the grade 9 concepts that we learned last year. So in order to calculate the slope, what we did was we compared the rise and the run, and using this formula, slope is equal to rise over run. We would take this smaller number divided by a big number, and a small number divided by a big number would give us a small slope. However, in this case, we have a big rise divided by a smaller run. A big number divided by a smaller number would give us a bigger slope, right? Now, we want to connect this part here. Slope is actually connected to the angle here, this focus angle here. For this low, small slope, we have a small angle. For a huge, steep slope, we have a big angle. So, the steeper the slope, the greater the focus angle. And now we're going to try to use some of the labeling knowledge I've used before. Remember, this was our focus angle. Across from the focus angle is the opposite, and next to it is the adjacent. And across from beta is opposite. Next to beta is the adjacent. So the question now changes from which one has a bigger slope to which one has a bigger ratio when we divide these two things. So we're no longer talking about rise and run in grade 10. We're going to be talking about the opposite over adjacent. Okay, so in this case, I'm going to try to review. When we divide the opposite, which is a small number, smaller number than the adjacent, we're going to have a smaller ratio, right? I'm going to divide these two. This will be a small number. Here, if I divide opposite, a huge opposite divided by small adjacent, this would be considered a bigger number because we're dividing a bigger number divided by a smaller number. So the ratio here would be bigger than this one. So we're going to put all those ideas together and introduce something called the tangent ratio. Now that we've taken a look at a couple of building blocks preparing us for this tangent ratio, we can dive right in. So, taking a look again, we have a 45-degree triangle, and what this 1 means is that this opposite is 1 times bigger than the adjacent. And 1 times bigger really means the same size, which is that isosceles triangle thing we were looking at a couple of slides earlier. Now, what happens if I actually increase the angle from 45 all the way to 46? So if I change this to 46 here, do you see how it opens up? And the side is actually bigger now because this is a bigger angle. If you open up the angle, the mouth opens up to a bigger side. And as a result, this is going to be 1.0355 times bigger than the adjacent. Let's make it a little bit more obvious and actually open up the angle even more. So if I change it from 46 to 70 degrees, you can see it for a 70-degree triangle, the opposite is now 2.74 times bigger than the adjacent. So you can see how it's getting bigger and bigger. The opposite is getting bigger and bigger and bigger. And if we go even more extreme to an 88-degree triangle, which kind of doesn't even look like a triangle right now, but this is supposed to be a right angle triangle here, which I couldn't fit in. Do you see how this opposite now is 28.63 times bigger than the adjacent? That means I need 28 of these adjacents in order to make up the length of the opposite. So how am I getting all these numbers? I'm getting all these numbers through the calculator button called tan. So what I want you to do right now is to actually type in tan 45. If you type in tan 45, it's going to give you 1. If you type in tan, click this button, tan, and the focus angle, 46, which is what this data is asking for, so tan 46, it'll tell you that the opposite is 1.0355 times bigger. And if you put in 70 degrees, it'll tell you 2.74, and tan 88 will tell you 28.63. And so when your calculator is punching out these numbers, you have to actually make sense of it. You are better than a machine. A machine has no understanding of what these numbers mean, but you have to know that this is a triangle. You have to understand that this is a comparison between opposite and adjacent. Okay? So what I need you guys to do is that every time you use the calculator and you type it in, type in tan 70 or tan whatever number, you have to understand and interpret what that means. And you can interpret it using this sentence right here. Therefore, the opposite is 28.63 times bigger than the adjacent. Okay? So let's go to the next slide here. This is a trig table, and this is basically what your calculator has memorized. And so I'm going to show you again. We did tan 45. Tan 45 outputted 1. Your calculator has just memorized that every 45-degree triangle has the opposite is 1 times bigger than the adjacent. And if we do tan 70, what pops out is just this table. The calculator is just accessing this table and just memorized it. So tan 70, the opposite is 2.74 times bigger. Tan 88, 28.63. Okay, now, what happens for every triangle less than 45 degrees? What happens if our focus angle is less than 45 degrees? See this? We change it to 27 degrees. And you notice a difference now where the opposite is actually smaller than the adjacent. Over here, the opposite is bigger than the adjacent. The opposite is bigger than the adjacent. But when our angle is smaller, now our opposite is smaller than the adjacent. Okay? So what this is saying is that this is 0.5 of the length of the adjacent, or half of the length of the adjacent. That's what happens when the angle gets smaller. And if you want to change it to even percentages, it might make more sense to you. Change this decimal to a percentage, it's 50%. The opposite is 50% of the adjacent. And your calculators basically memorize that. And if we type in an even smaller angle, let's choose a smaller angle, 8 degrees. If we type in tan of 8 degrees, it's going to pop out 0.14. And what does that mean? That the opposite down there, if you take a look down there, the opposite is 0.14 of the adjacent, or 14% of the adjacent length there. Okay? So the calculator's just memorized that table for you. It's not doing anything magical, it's just telling you the ratio of opposite to adjacent. So that's what tangent really is. It's just a formula of opposite over adjacent, and your calculator's basically memorized every single ratio. And I just want to tell you that it's just another relation. We've been studying relations in grade 9, where we related y and x, and y is any dependent variable and x is any independent variable. And we worked with pizzas, like number of toppings and cost, or taxis, where number of kilometers driven and the total cost, right? You're relating any independent variable with any dependent variable. And that was the same with last unit where we did quadratics, where we related any x value with the y value, and there happens to be a square value there, which made it quadratic. And this described a lot of projectiles like firecrackers or things we launch in the air like rockets. Okay, it's just a relating between time and height of the rocket, or horizontal distance of the firecracker and its vertical distance. This is just relating the angle with the ratio. Every angle for every right angle triangle has a ratio. Okay? And we're just relating angle with the ratio of opposite to adjacent. And so that ends our tan introduction. Please click to the next video for example number 1.